Welcome. Today we try to understand how to draw spectras of UV, visible, infrared and XRD. These spectras can be drawn with the help of Origin software. This software is very useful as well as popular in researchers. The main important things we require for analysis is the txt file. Nowadays, operators of the instrument does not give us a spectra. They provide us txt files or ASCII files. So you must have an knowledge to draw a graph or spectras from that txt file. It is possible with this origin or by using this origin software. So what we require downloaded installed origin software in your computer and the txt file got from the operator. Okay, so let's look at that, how to analyze that txt file or how to create a graph from txt file. So you just go to the Microsoft Excel worksheet. In that we have a data. Click on that. Then from text you have to go to the file destination, means where is the txt file. So I know where is my txt file. I go to there, desktop, then origin, and this is my txt file of UV visible spectra. Now I am going to import it. Just click on import and then next, then check boxes are there. So click on semicolon, comma and space. Then next and finish. Click on OK. You will get two columns. One is for wavelength and one is for absorbance. So just copy this, select column A and column B and copy it. Now go to the origin. This is the origin 6.1. Now here there are two columns A and B. You have to paste that copied data here. Okay, so you have pasted here. Now select again column A and B. Column A is for x-axis and Y is for, or B is for y-axis. Now go to the plot and then line. You will get the UV spectrum of your compound, but this UV spectrum is not useful as such because we need to do something with this. What is that? We should have some title for x-axis, title for y-axis, and title for the spectra, and we also have to assign some values in your spectra, or you have to find out the lambda max values or the peak position of your spectra. Now just first task is you have to go to the axis by clicking or by right clicking on your spectra, or then go to axis. You have to select the range, UV range. Basically UV ranges from 200 to 800 UV visible. So you put here 200, starting from 200 and end up with the 800. That is range for UV visible. Apply it, then you have to go to the title and format, then start with the bottom. You have to increase the thickness, just make it 2, apply, then go to the top. Here you have to click here, show axis and ticks. Now we don't want ticks, so you have to say none for ticks and also increase the thickness. Apply it, then go to the left. This here show axis and ticks. Now you have to just increase the thickness by 2. Apply, then go to the right. Again click here, show axis and ticks. Here automatically we have none, so no need to change, and increase the thickness to apply. Okay. Now your spectra look like this. Then what you can do for this, you have to keep a title for x-axis and y-axis. Now click on OK. Then double click on x-axis. Give a title. What is the title? Wave wavelength. And it is in nanometer. Okay. Make it bold and give some color. We say we give wine. Okay. Then for y-axis title, it is absorbance. Again make it bold and give color suppose blue. Okay. Then you can give color for this one and make a bold. Then give color, same color we give, that is wine color. Apply. Then for absorbance also you give color, your blue color, and make it bold. Apply. Okay. Now you have to change the color of this spectral line. You just double click on spectra. You will have this window. You select your color. Also increase the thickness or width of your spectral line. Apply it. Your picture will look like this. Okay. Now say OK. You can give name for your spectra. Suppose this is spectra for NiCl. Cl4 6H2. Now your Cl2 and H2O2 should be at the bottom. So just click on X2, again select H2 and click on X2. Okay. Now select whole thing, make it bold and give color. Suppose we are giving this one. Okay. You take this inside the. Now you have to find out the peak position. Go to the tools, peaks, and now what we want, the positive. So you remove this negative. Just make it show 1.5, then 5. say fix, find fix. It is going to find the peak position 418, 620 and 695. Those are the lambda max values in visible region or NiCl to 6H2. Now, after this, close this. You have to export this spectra to have good quality. You have to export this spectra, go to the file and click on export page, give name for your file, suppose it is NICL. Then you have to save this in the form of if file and give a destination. So just I am going to save it on desktop. So say save. I have already saved name file, so it will show like that. So you get the saving of your file in the form of TIFF at your desktop. So I have this TIFF file here. Okay. Now this is, you can copy this and paste in your Word document. You can crop this, but you will not have change in quality of your picture. See, if you zoom it, you will have same look as it is over there. So to have quality, you have to export that in the form of TIFF file. Okay, this is for UV. We can find out the respective lambda max or whatever lambda max is possible for that UV spectra. Again, you can analyze IR data. Suppose we have IR data available with us. Again, we go to the data and from text, this is supposed to be a txt file of my IR data. I am going to import it. So next, again click on semicolon, comma and space. Say next and finish. Oh, we get those two columns. Column A is supposed to be a wave number and column B is the percent of transmission or transmittance. Okay, so you have to copy this and again go to the origin. Now here, to draw IR spectra, we need to take new project. So click on new project. Okay. Now ask for save project, which is already done. So we say no. Now we paste our copied data here. Again, select the column A and B and again plot. You'll get the spectra like this. Okay, this spectra is the IR spectrum of our selected data. Now, this IR we should have like this. It should start from 4000 to 500. So for that purpose, double click or right click on your spectrum, go to the axis and put here 4000, starting from 4000 and to the 500. Apply, you'll get such picture. Okay, Now again, similar to that earlier one, again you have to go to the title and format. You have to increase the thickness to, then you can apply it. You see here. Then go to the top, click on show axis and ticks, make it none for ticks. Again increase the thickness to, apply, go to the left, again increase the thickness to, apply, go to the right, click on show axis and ticks. Now just increase the thickness to, apply, and say OK. Now you have to give a titles. For x-axis it is wave number, and it is in centimeter inverse. So by selecting -1, you click on X square, it will go at the top. Now you can make it bold and select the color white. Say OK. Then go to the y-axis, double click, you will have %T. Make it bold, give color blue. OK. You can give color for this. Make it bold, color that is wine. Apply, make the left, mold, then color is blue. Apply. OK. Double click on this line. Select the color. Suppose we select purple color. Make this 2. Apply. I can make, okay, it's okay, 2. OK. Now your spectra is ready. You can give name for this. This FDIR spectra. Bold and blue color. Say OK. Take it inside. Okay. Again, same procedure to extract or export. Export page. Give name IR. It will get saved at desktop. Again, destination is same. Zip file. Save it. Okay. Now, again, you can have XRD plots here. Again, you can export or import the data from txt file. Here it is the txt file for XRD. Import, next, next, finish. So column A is 2 theta value, column B is the intensity. Copy this and go to the origin. Again take new project, say no, paste the data, copy it here and plot it. You get this as XRD, graph of XRD. Now Again, right click, go to the axis. You have to start with 20 and end up with the 80. Apply it, and again go to the title and format. You increase the thickness, say 2. Then top line, show axis and titles. Make it none for axis. Ticks. Then increase the thickness. Apply it. Select. Just increase the thickness. Apply it. Go to the right. Show ticks and axis. Increase the thickness. Apply it. Oh, so it looks like this. Now give axis title. For x-axis it is 2 theta. So we give theta like this. We put q, and in your font you type symbol. Symbol. So you have theta here. Okay. Now make it bold. Hue color. What we use? Wine color. Okay. Y-axis title is intensity. Make it bold. Hue color blue. Okay. Hue color for axis. Values. Make it bold. Blue. Apply. Then to the bottom. Make it bold. Then wine. Apply. Say OK. Now, in this case, we can find out 2 theta values exactly for that particular peak, or where at what 2 theta value we have this particular peak or this one or this one. Okay, so for that we go to the tools, peaks, and just make some changes in width and height. 8, 10. And this is as per our requirement, or this is as per the spectrum look like. So we got this 40.06, 46.64, 68.18. Okay, now you have to give color for this. Double click on this, you get color here. You can give color purple. This you can make little, you can increase this. Just apply it, you get this particular look for your spectra. You can give name, say OK. You can give name for this. It is what? XRD. Make it bold, give color, say OK, take it inside. Okay. Now you can again export this file as like UV and IR. Go to the export page. Again give a name. Suppose it is XRD1. Save. It will get saved there on desktop. So we have XRD1. This is the file. You can copy, paste in Word file and crop it. Okay. So likewise, we can draw a graphs of UV visible, IR and XRD by use of Origin software. This might be useful for the students, those are working as a project students, as well as this is very useful for researchers and teachers, those who are interested in this particular area. So for analysis as well as graphing purpose, this software is very useful.